All right, so welcome back from spring break. Hopefully you had a good spring break, that you were reset and you're all ready to get back into it. I will remind you that the Gantt chart, you could still be following that. You'll note here that as of this phase, however, we don't have everything mapped out, right? You got the first few phases of this course. You got the first half of this course basically for free. At this point, if you're going to continue using the Gantt chart, you need to map that out for yourself, okay? Again, planning is part of the process. That at each one of these, the beginning of each one of these sprints, you should be planning out your next 2 weeks or 3 weeks or whatever it happens to be. And only you can do that because only you know your schedule. So I'll go ahead and get rid of that. Remember that we were talking about databases, SQL, and all that stuff. If you have any questions, go ahead and post to the live stream. Otherwise, we left it off by creating this database. We implemented this database to support our account system that we had over here. Remember that we have an account, and we have two types of accounts, an annuity and a savings account, each one of them owned by a person. Except over here in the database, what we did is we said that ownership is now actually different. That you can have multiple owners on the same account, and then one person, of course, can own multiple accounts. We did that through a many-to-many relationship between the person and the account class here. Over here in the email table, we had an email table to model a one-to-many relationship between the person and the email table so that one person can have multiple emails. Over here in the account table, what we did to model both an annuity and a savings account is we used a single table inheritance strategy, meaning that we put the monthly payment and the number of years in for annuity accounts, and then we put the balance in the APR in here for savings accounts. And the way that we distinguish those two things is through this type column here. Remember that we called that a discriminator column or a discernment column, right? It was a single character here indicating A for an annuity account or S for a savings account. Now that we've done that, let's go ahead and wrap this up by making some observations about our design and that design process. First of all, the first observation that I want to make is that, again, just like object-oriented programming, semantics dictate design, right? You usually have one entity per table. So if you look over here at our UML diagram, right, we have annuity, savings, and then we have a person account and an account up here. Well, it doesn't have a nice clean mapping over here to our database, but it does if you consider that you've collapsed the inheritance hierarchy into one class, right? There's one class over here for accounts. There's one class over here for persons. There's one table over here for emails. And that's because we didn't have an email class, but that's because Yagni, you ain't gonna need it, right? It's what is an email? It's just a string. But in the terms of a database, of course, you need to separate these out for a one-to-many relationship, and so you do need a table over here, right? It's not 100% clean mapping between these two models, because one is an object-oriented programming model, and one is a database model, a relational database management model, and so you do have to map between these two different models, okay? Some style tips. Right? As long as you are following a consistent naming convention, you're going to be okay. If you want to go with an old school underscore casing convention, for example, table name yay, right? There's an underscore casing convention, or a snake casing, some people call that. And I don't like that because it's simply because, one, it's not modern, right? It's really, really old. But also, what are you doing the entire time when you're typing? You're taking your pinky and you're putting it on the shift key, and then you're going across the keyboard to hit that underscore, right? Save your pinky, save your arthritis, and just use a modern convention, right? So be consistent with naming, right? The suggestion is that tables should have a, or an, upper camel casing convention. And columns should have a lower camel casing convention. Avoid pluralizations and abbreviations. In fact, this is exactly the same advice that I give with Java. So why am I giving this advice now? Because there's going to be a one-to-one mapping, virtually almost, between your tables and your Java classes. And if you're using the same naming conventions in both, it takes a lot of guesswork out of the entire process, right? Other suggestions, so other style tips here. Make sure every table has a primary key, which is going to be an int, not null, auto increment. Oops, increment. There, got to spell it correctly. There we go. All right. Why? Because that gives you a consistent layout. That gives you a consistent structure to your database. When you do that, make sure that you use a consistent naming convention on that as well. Use the table name plus ID, right? So for example, person ID or email ID, right? If you're following that convention, then you should be good to go. Now, you'll find in your project you're going to need to make several foreign keys to, say, a person table, and you can't name them all person ID, in which case you do need to start using a different, more descriptive name, salesperson ID or customer ID or something like that. Right? Foreign keys should have the same name as the primary keys that they reference. Right? Right? So for example, over here, right? Here's the foreign key mapping back to the person table. What did I call it? Person ID. Why? Because it references the person ID in the person table. Right? Again, taking guesswork out of this process by using consistent naming conventions, and it also saves you the need to think of these clever things. Right? Account ID. Account ID over here in the account table is a foreign key with the exact same name over here. Definitely do not use strings as keys, or as foreign keys or primary keys, right? Strings, in other words, varchars, outside there, should not be used for primary keys or foreign keys, right? Because there's casing issues, there are encoding issues, and of course there are efficiency issues. It is much easier to compare two integers, and are these the same integers, than it is to compare a string that might be 100 characters long. Then you have casing issues. Is lowercase h hello the same thing as uppercase h hello, right? Hopefully not, right? But depending on how you created the table, the default settings of the database, the collation, how you create your query, all of that stuff, 50 different things could go wrong. Nothing goes wrong when it's an integer, right? An integer is an integer is an integer, right? No guesswork there at all. Join tables should be created or used to model a many to many relationship. Right? Tables, there we go. Right? Be sure to insert plenty of test data into your database. In fact, that's going to be a requirement. All right. Remember, how did we suggest that you generate data for the first two phases? You go to test data or mockdata.com or whatever, and you generated all this stuff. Well, how did you generate a test case given that input data? We want to know what it looks like in JSON. We want to know what it looks like in XML. We gave you a csvconverter.com reference. Guess what? When you look at that website again, you'll see that not only does it have output as XML and JSON, guess what else it has? Output as SQL, right? It shouldn't be that hard to insert a lot of test data if you're using the tools that we're giving you, okay? Check uniqueness constraints and enforce data integrity, basically good modeling, right? It's not that common, but we saw a lot of folks storing, say, like a price per unit in Java as a string for whatever reason, right? It's not a string, it's a number, right? It's a double. Make sure that you are choosing the correct columns, varchars for strings, doubles for things that are floating point numbers, and integers for things that are integers. There are other values, for example, date. The way that we did that with date of birth over here is we used a varchar 10 because we used 8601 standards. Some database systems do allow you to use dates. Some database systems allow you to use blobs, right? You could store binary large objects into them. Floats, just a less accurate double, don't do that. And there are dozens of other different column types that you probably won't need. YAGNI, you ain't gonna need it, at least for as far as this course goes. This is just an introduction to databases, all right? And it's only one part of the entire process. All right, let's see. There's a lot, yeah, I'll go ahead and save this for later. So any questions so far? No? So then let's go ahead and talk about normalization and the 3 normal forms that you can have. So this is what Edgar Codd originally came up with these when he made the relational database model. There's first normal form, second normal form, third normal form. That's what 1NF, 2NF, and 3NF stand for. Now, it's all built on top of each other. So in order to be third normal form, you need to be second and first normal form. In order to be second normal form, you need to be first normal form, right? So they build on each other. Right? You cannot have a higher normal form without having all lower normal forms. And just in case you're wondering, is there fourth normal form, fifth normal form, and beyond? Yes. We won't get into that. That gets into temporal databases, and that goes beyond the scope of this course. So let's go with each one of these in order with first normal form starting first, right? So what is first normal form? Right? A quote here. Each attribute, in other words, each field or each column in a table only has atomic values. So what is an atomic value? Atomic as in the original meaning of atomic, atom, indivisible, right? That this one piece of data, or what this one column represents one piece of data and not multiple pieces of data, right? So each column represents only one piece of data, one value, right? It's helpful to think of these things in terms of what would violate first normal form, right? So what's a typical violation? For example, if I stored a comma delimited list of emails in the email instead in the person table instead of a separate table, right? So for example, over here we have a one person table to a many email table, right? I did that immediately because I wanted to normalize this data. One alternative is to say create a column over here in the person table that was labeled email addresses. And then I had the first email address, comma, second email address, comma, third email address, et cetera, just like they are in the CSV files. The CSV files are a flat data model and not a relational data model. So that would be a violation of first normal form over here when you're trying to normalize data. Separate them out into different tables. Here's another violation that's all too common, right? Suppose that we only want to support 3 emails, right? Having columns, email one, or let's call it email 1, comma, email 2, comma, email 3, right? Anybody who gets out of a computer science 1 course knows immediately that this is wrong if you think in terms of variables, right? If you created a person class, would you go variable 1, variable 2, variable 3, right? That's something that somebody does in the first week or something, right, like that. And then they immediately think, okay, there's got to be a better way of doing this, right? And then they get to week, I don't know, 6, 7, whatever. If you're coming from a Python background, hopefully immediately with lists, right? But if you're coming from a C background, maybe in the 7th week when we start covering arrays, right? You start thinking about collections of these things. Well, what is a collection with respect to a database? It's another table, right? Do not follow this pattern at all. This is a violation of first normal form, right? So be sure to separate data out into separate tables as necessary. Yeah, go ahead.
The first thing I think of, because emails are already a list within the person class, that's just kind of how this had to be designed to store the data in Java.
Sure.
How would that translate over into, from the database back into Java? How would we recompile that list?
That's a good question. So the question for those online was, how do we reconcile these two things, right? This is not a list over here, but it's a separate table. Over here, the way that we modeled it is a list in the person class. So how are we going to load up the data? That's exactly what we're going to talk about after we finish up with databases. That's JDBC, Java Database API Connection, right? So you're going to write Java code to connect to your data. Right now, the way that I'm connecting to my database is through my SQL Workbench. I'm making a bunch of queries and I'm executing them, but that stays in my SQL Workbench. What I want is a programmatic way of connecting to the database, and that's what we're going to do in Java. You write your SQL code, you put it in as a string in Java, and then you execute a query and pull back and get a result set back that you then process in Java. Right? And that's the way that we're going to go with it. Right? So once we've wrapped up databases, though, probably starting today here. Right? All right, so it's make sure that you're defining, separating out everything into in another table, and you're not violating first normal form. Second normal form is really, really simple if you've been following my advice, right? That using a, here, I'll read it in a second here, but using a primary key auto-generated, not null, gets you second normal form for automatically, right? So if you've just been following good practice, like I've been trying to impart on you, of making sure that every single table has a primary key named after that table that's an integer, not null, auto increment, you're good to go. You don't even need to worry about second normal form. But what is second normal form? It has to be, first of all, first normal form. And then no non-prime attribute is dependent on a proper set of the prime attributes. Right? That's kind of difficult to parse. So, so to make it simple, let's look at something that would violate second normal form. So a violation would be, say, a purchase record, hint, hint, purchase record, that contains a customer ID and a store ID and, say, a store address, right? A record. Right? That would be a violation of second normal form. Why? Right? As if the key, the primary key, is a combination of customer ID and store ID, the store address is only dependent on the second part. Right? That's a store thing. So you see a parallel immediately with object-oriented programming. Encapsulation, right? Where should store stuff belong? In the store class. Where should store data belong? In the store table, right? Don't muck them up and violate second normal form. This table is for this table stuff only. This table is for this stuff only over here. If you need to bring them together, you bring them together in either a join table or in a one-to-many relationship, right? This store address has nothing to do with this customer, right? It only is dependent on the store ID. And so it's a non-prime attribute, a column, that is dependent only on part of the prime attribute using this primary key combination. Again, if you go with what I've been suggesting and just use a primary key, not null, auto increment, you get this for free because there's no such thing as a key combination of two or more columns. Right? So if you're just following the instructions, you'll get this for free. It's often useful to have key combinations, right? Things that are dependent on two columns. In fact, we did that over here, remember? This ownership table. We made the combination of these two primary keys, or these two foreign keys, unique. Do you remember how we did that? We defined a constraint, unique pair, on the person ID and the account ID. Why? So that this person owns this account, not this person owns this account. Person 123 owns account ABC. Person 123 owns account ABC. Person 123 owns account ABC. Why repeat that 3 times when you can have a unique pair that that person owns that account, period, right? That person doesn't own that account 3 times or 4 times or 5 times. And so there is our use case for having a key combination, but it should not be a primary key. It should be a secondary key or a constraint or something like that, right? Again, the idea here is split everything out into its own table logically, right? It's not that, I mean, it's basically intuitive, right? That doesn't look right. I need to separate those out. Right? Third normal form has to be 2 normal form and transitively 1 normal form, right? Hopefully we remember transitivity from 235, maybe you haven't gotten there yet. 235 discrete math. A is related to B, B is related to C, therefore A has to be related to C. That's transitivity, right? If you can go from A to B and you can go from B to C, then that means that you can go from A to C. How? By going to B first, right? So third normal form is both of those normal forms, and then of course transitively the first normal form, right? Its statement is as follows. No non-prime column is transitively dependent on the key. So we've got two notions of transitivity here, right? So here's an example, all right? So suppose that we had over here in our table, actually over here in our Java classes, we have a function that is get value. Do you remember what that looks like for a savings account? Let's open that up and look at it. Give myself some more room here. All right? Where's the value? What's the value of a savings account? It's simply the balance. But what's the value of an annuity account? There's the value. It's the monthly payment times the number of terms times 12 because you've got 12 months in a year. Of course, we're going to store the monthly payment and we're going to store the number of years in our database, right? We need those. But what didn't I store in here? I didn't store this times 12. Why not? Because it's transitively dependent on those first two. If I had stored that third one, that would be a violation of third normal form. So, an example, storing, say, term years and what is it? What would I call it? Term years and monthly payment. Monthly payment for an annuity account, but also storing the value, right? Which is term years, I don't want to retype this, term years times monthly payment times 12, right? Where should that be? We call that business logic, right? That value should be in the code, Java. It's not data. It's the only thing that's data here is term years and monthly payment. What is this thing right here? That's behavior, right? That is the value of, given these two pieces of data over here, what is the value of this entire account? It's this times 12, right? That's behavior. That belongs in an object-oriented programming model. It does not belong in a data model. The only data that's necessary here is term years and monthly payment. Imagine if you did store all three of these things, right? And then you go in and you change the number of years. What happens to the value? Is that correct anymore? Nope. So that gives rise to potential for data anomalies, right? So storing data that is dependent on other data is wrong, right? It gives a failure point, right? That it introduces a possible data anomaly. Anomaly. Is that how you spell it? Switch the O and the A. O and the A?
Yep.
All right, spell checker agrees with you. Good job. All right, so don't store those things. It gives rise to data anomalies. If one value changes, then the other values may need to do so as well, right? And that's what we call business logic, right? That's what we call program logic. That's what we call middle tier logic, whatever you want to call it, right? That stuff belongs in code. That stuff belongs in the object-oriented programming model because it's behavior. Databases are data. Databases don't have behavior, right? Or they shouldn't have behavior. So don't do that, right? A nice little mnemonic device here that you can use to remember third normal form is that every non-key attribute must provide a fact about the key, first normal form, the whole key, second normal form, and nothing but the key, third normal form, so help you God, right? So you need to tell the truth, the whole truth, and nothing but the truth, so help you God. And now we've got COD here, because it rhymes, right? A little nice mnemonic device to help you remember what the three normal forms are, okay? All right, so there's a lot that we didn't go over, right? Because this is not a database course. Even in a database course, you probably wouldn't go over everything that's of practical use for databases. You'd probably go over like B trees and internal data structures and stuff like that. But there is a lot more, right? If you're interested, you can take an online database course or something. For example, triggers, right? Views, stored procedures, and variables, etc. Right? So what are triggers? A trigger is something that you can set up that, so for example, when somebody logs in, I want to know the last time that they logged in. So on systems where I'm handling login management, I've often put in a column that said last login date, and it was a date timestamp, so that I could find out what was the last time they logged in, right? And that was set up by a trigger. Anytime that this thing over here was changed, then it triggered a procedure for updating that column to the current date and time, right? Or you can set up a trigger to basically do anything. When that gets updated, update that thing over there. Or when that gets changed or deleted, update that thing over there, right? And that's what a trigger is. You can set those up if you're really into database management administration, DBA, database administrator. You can also have views, right? So if you don't trust your middle tier Java folks to insert correct data, or not to screw up your data, you can set up what's called a view. It's a read-only access to, say, a table, right? So somebody can go ahead and pull data out of that table, but we're not going to trust them to update, insert, or modify the data or delete the data. So we're only going to give them, remember CRUD, create, retrieve, update, and destroy. We're only going to give them R, retrieve, so that we have assurance that that account, that person that we gave access to, they can't muck with our data. They can only read it. You can also be more fine-grained about it, right? If I've got if I've got a table with 5 columns, I can grant access to, say, the first 3, the first name, last name, and NUID, but maybe their date of birth or their social security number. Those are things that I want to keep separate, so I'll give them a view that only gives you access to those first 3 things, right? And again, since it's not a real table, it looks like a real table from the perspective of a query, but it prevents bad actors from mucking up with your data, right? And also gives you a little bit of more fine-grained security with your data. Stored procedures are exactly what they sound like. They're basically functions that you can write, and those functions are written in SQL. They're not written in C, they're not written in Python, they're not written in Java. They're written in SQL. And they're procedures, so step 1, step 2, step 3, step 4. And you've got an entire language of things that you can do, right? That way that you can take some more complex query where you're creating a temporary table and you're putting the data into it, making a data crunch and then producing a report. You can take all that complex logic that's maybe 20 lines of SQL code, you can put it into a procedure that then you can call that procedure so that you don't have to worry about the details of that procedure. You can also have variables, you can have loops, you can have a whole bunch of things. You can have basically SQL is a regular programming language. You can treat it as such. They're called cursors, I believe. They're not really variables, they're called cursors. And you can get into a lot of really low-level database administrative stuff. Again, it goes way beyond the course of the scope of this course, and certainly the scope of this module. But I want to make sure that you're aware of these things and that they are out there. So that, can I create a variable in SQL, in the SQL language? Yes, you can. Go read about it at your local library or something, right? Transactions, right? All or nothing, series of queries. They're queries. Can't spell today, right? So over here, over here in MySQL Workbench, I've got a whole bunch of queries. I've got 4, 5, 6, 7, 8, 9, 10. I've got 10 different queries here, right? If I execute them all, right, then I can treat them as an all or nothing thing. All 10 of these things should execute, or none of them should execute at all. By default, each one that you execute is its own transaction. This is what we call them. I could take those 10, let's go ahead and simplify it, 5 queries. I could take those 5 queries and wrap them up into one transaction. This gets into the ACID principles, atomicity, right? Such that, suppose that everything goes right, the first one is correct, the second one, third one, fourth one, fifth one, all of these queries are correct. At the end of it, everything will be correct in my database. But what if something goes wrong? The first one goes fine, the second one goes fine, the third one goes fine, but the fourth one, that's where I've got an SQL error or a data integrity error. I am violating some rule of my database that I set up, right? Since I wrap this up into one transaction, it's an all or nothing thing. You will not be in an intermediate state where the first three worked, but the fourth one didn't, therefore the fifth one never happened, right? This is an all or nothing thing, so it rolls back to the beginning. The three things that worked never happened because the fourth one failed. And that's what's called a transaction, right? And by default, each query by itself is a transaction, but you can start a transaction, right? I think it's start transaction, right? There we go. Something like that. I forget what it is in MySQL. And then if anything bad happens, you can say rollback transaction. And it's like it never happened, right? Oopsies, right? It rolls back the entire transaction. I think it's just rollback, actually, but I forget. Each database system has its own keywords for doing this. And then the opposite of that is committing a transaction, right? Everything fine, 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 fine. Everything went great, great. Now commit it, right? Everything is great. Go ahead and commit it. I want all that stuff to happen. It's an all or nothing thing. And that's what a transaction is. Again, by default, each one of these queries is its own transaction. But you can wrap up the first three in a transaction, commit that. The next four in a transaction, commit that or roll that back. And we will do that when we get to JDBC, right? There, by default, everything is its own transaction as well, though, right? There are lots of security issues that we never talked about. For example, don't store sensitive information in a database. For example, unencrypted or unhashed passwords. This is by far still the number one way that people gain access to systems. All they need to do is gain access to the database. And if it's a bad database design and they stored passwords, all plain text, guess what? Right? Now they've got all these passwords. Even if they store it hashed, if they don't do it correctly, then they can use what's called a rainbow table to look up common passwords. What do you think the most common password is? Password, right? The second one is 1, 2, 3, 4, right? Or, nope, a minimum of 8. Okay, fine. 1, 2, 3, 4, 5, 6, 7, 8, right? 40, then 1, 2, 3, 4, 5, 6, 7, 8, right? Or something like that, right? Some word repeated over and over or something. And those are very easy to crack, even if they're encrypted, even if they're hashed. Why? I know what the encryption function is. I can take a password, the word password. I can encrypt that and see, does that match anything? That's what a rainbow table is. You take the most common words or an entire dictionary or the most common passwords, you pre-hash them all and you see what the hash looks like, and then you look and see, well, does anybody have that hash in the database? They do. I know what their password is now. Their password is just password, right? And this is the most common way of getting passwords. In fact, you can check yourself, right? Let's see. Have I been pwned? How do you spell pwned? P-W-N-E-D. There we go. P-W-N-E-D. Thank you. Right. So, I don't know. Let's put in my email. Have I been pwned? unl.edu. There we go. Good news. No pwnage found. Excellent. Now, I'm not going to ask for any volunteers here because I don't. You could be on some shady website or something, and you don't want anybody to know about it. But you can check for this. Have I been pwned? To see if you have, if somebody has broken into a website, stolen a bunch of passwords, either encrypted or hashed, and see if somebody has broken that common hash. Right? I don't know. Does anybody want to volunteer? I don't know. We could pick on some administrator or something. Who's not Harvey Perlman? Who's our chancellor now? Ron? Yeah, go ahead.
I checked mine. I did get one.
Okay. Is it non-embarrassing?
I don't know. Wait.
Well, it'll tell you the websites. Okay.
Wait, do I just scroll down?
Yeah, it should. Yeah.
Okay, hold on.
I don't know.
You just type it in. No. You did get one?
Well, yeah. Go ahead.
Eldin, E-L-D-I-N, Salja, S-A-L-J-A, @gmail.com.
All right. Let's find out where you've been pwned. Oh no. So you joined Quid? What the hell is Quid? I don't know. So somebody joined on your behalf. Online marketplace for trading stickers, cards, and toys. Ooh, you like stickers. You didn't know you liked stickers, but you do, right? The breach exposed 4 million users' email addresses, usernames, and password stores as bcrypt hashes. So that's pretty good, right? However, if whoever you made this account for you used a common password like password, then you could check to see if that if it's been broken. If you used a strong password, some random value or something like that, or a dictionary phrase or something, then you probably are still okay. But somebody has your hashed password. Right? Now that's fine in a actual system, because every time you log in, a good system. Oh, okay. Somebody was really phoned. So you might every time you log in, they might add a salt to it, right? So does anybody know what hash refers to? What does hash mean anyway? So hash browns. Think about hash. Everybody's had hash browns at some point, right? What is it? It's a potato that's been cut up, right? That's what hashing is, cutting something up. So now you know why we call it the hash mark, right? The hash mark, the hash symbol, right? That thing. Why do we call it the hash symbol? Because it's been cut up, right? Like hash browns, right? That's why it's called the hash, right? And so, where was I going with that? Yeah, you could, salt. So hash browns, of course, to make them tastier, what do? You salt them, right? You put in a little bit of salt to make them taste better. Or you put ketchup on it, and you like ketchup, why? Because it has a lot of salt. Anyway, you add a little bit of salt. In other words, if you have a password, my awesome password, 1234, right? It'll add some salt to the end, some random value to defeat this rainbow table type of attack. Because what you need to do now is you need to not only take this, to break it, you need to take this common password, but then you need to try every single possible salt after it. And then you need to recreate the tables. And that way it defeats this rainbow attack kind of thing. Right? So check yourself out, see if you have been pwned or not, right? And do it privately, because you never know what sites you're on. Right? Quid turned out to be pretty safe, but there might be other sites out there that are not. Right?
My Outlook email got hit in 4 breaches.
There you go.
That's why I was so loud. I was like, God damn.
Yep.
I can't even.
So go change your password, right? And if it's a good system, that salt will be changed every single time you log in automatically, right? Another item that you might think about doing, and don't do this for your project because I'd say that it falls under YAGNI, you ain't gonna need it. But there's a concept of a hard delete versus a soft delete. A hard delete is when you use the actual delete statement. That data is lost and gone forever. There is no undo. You can always go to a backup of your database, say a snapshot from last night at midnight or something like that, and restore some of that data. But a hard delete means it's gone from your database. A soft delete is a little bit different. It involves defining a Boolean column called isActive. And now what does a delete do? A delete simply sets that value to false or deleted, right? Some flag value to indicate that data is no longer active. So I've done this in many database systems because I knew that I can't trust the users, that if I give them access on the front end to delete that data, put up a dialogue, are you absolutely sure you want to do this? This cannot be undone. Yes, right? And then if you're really paranoid, are you absolutely sure that you want to do this, right? Yes, and now they've deleted it, right? And then they come back to you and say, despite those 2 warnings that you gave me, I deleted it and I shouldn't have. I go, okay, well, that's too bad. Remember that the message did say that it can't be undone, right? Okay. Oh, well, that's too bad. Okay, let me see what I can do for you, right? And they're in a panic or whatever, right? And you go back and you start twiddling your thumbs, and you know that you set a soft delete to this. So you know all it is one SQL statement to set a 0 to a 1, right? But you take as much time as you want, right? And then you come back to them a day later and say, I worked the last 24 hours straight, and I was able to restore your data. So give me a huge raise, give me a pat on the back, give me whatever you can, but I was able to restore all that data. And they didn't know, right? They didn't know that it was just one column and one table in one database, right? That's called job security, right? So think about that, right? And also the last thing that, of course, we've talked about before already is an OOP model versus a relational model. An OOP model basically allows you to use inheritance. It has behavior, right? RDBMSs do not have inheritance. They do not have behavior. So you need a way to resolve the differences between those two models. We talked very briefly about some of the options where you could have a table per class or a table per subclass, but our suggestion is to use a single table inheritance strategy. All right, where one table represents all subtypes, and you use a discriminator column to tell the difference. Like, that's exactly what we did over here, right? An annuity, these two will be defined, but for a savings account, they'll be null. For a savings account, these two will be defined, and the other two will be null. And then we also know the difference by keeping track of this type variable right here, A or S, depending on the two different types, all right? And then you can permeate that throughout your database depending on how many types you have, how many subtypes you have, right? So you use a discriminator column. Some columns might be irrelevant, but otherwise you use a discriminator column to tell which type of subtype you have, okay? All right. Any questions on databases, database querying, CRUD, the ADAM principle, ACID principles, I guess, which is, we never talked about that, don't worry about it. It's the atomicity, consistency, isolation, and durability. Those are the four things that a relational database management system will offer you as far as data integrity. They all ensure data integrity, right? But otherwise, what I wanted to do is move on to that programmatic access and programmatically connecting to a database and processing data, right? So the way that we're going to, usually every language will have some way of doing this. For Java, and there are several ways of doing this, but for the first time that we're going to do it is we're going to use JDBC, right? In Java, we'll use JDBC, which is Java Database Connectivity API, right? JDBC, Java Database Connectivity, and then API, Application Programmer Interface. If you've never seen that word before, interface, right? Basically, it's object-oriented programming, right? It's an interface. It's your publicly facing methods. What method can you call in this class over here to get something done, right? That's what an API is, right? This is actually an instance of the, dang it, 1 week and I forgot them. The solid principles, dependency inversion, right? The last one. And we'll talk about dependency inversion here in a moment. But what I want to do with the rest of our time here, and with only 5 minutes, is getting started. Right? One, download and install the connector J Java jar file for MySQL. Right? So to do that, I'm simply just going to go to Google. Right? Connector J, what is it? MySQL. Right? And somewhere on MySQL's work site, you'll have this developer, this download connector J. Download the most current version, which apparently is, well, once it gets loaded up. Oh, you're having trouble? All right. Whoa, nothing's dropping. Yeah, we haven't had any drop frames. I don't know if my connection is fine. All right, MySQL connector J. 8.0. Oh wow, it looks like their website is down. MySQL.com is completely down. Anyway, when they rack up or whatever, when a website is down, here's just a life tip. When a website is down, what can you do? Go to the Internet Archive. Spell it correctly, but Internet Archive. And what you can do is you can find, let's go back. That's what I want. Internet Archive, the Wayback, it used to be called the Wayback Machine, now it's called the Internet Archive. Go ahead and put in a URL, and throughout the lifetime of that, going back all the way to say 2000, right? It will have snapshots for the last 20 years of what that website looked like on a particular day. So let's go ahead and look at the most recent, which would be what, today is March, what? 13, oh, yes, oh, today. Oh, no, today is March 20th, right? So 1 week ago. We can go ahead and load that up. Come on. There we go. Oh, they were experiencing technical difficulties a week ago too? Maybe. I don't know. Go to another one. Go to that snapshot. We could probably take a look at what it looked like. There we go. Right now it's down, but whatever. Don't go with Microsoft Windows. Go with platform independent. I'm probably not going to be able to do. Oh wow, it does work. Cool. Platform independent. Download it. It'll end up being a zip file. Open up that zip file, and you'll find a jar file within that. It was something like connector J or something. Do not sign up. Do not log in. No thanks. Just start my download. And I'm not going to be able to download it right now because the entire thing is down. But eventually you will be able to download it. Oh, wow. Nope. I am able to download it. Good job, Wayback Machine. It's finding everything for me today. Anyway, it's just a tarball. Here's what the tarball looks like. Looks like this. And over here, you don't want source. There's your jar file. Right? Take that jar file and put it in your Eclipse project. Your Eclipse project should already have a data or a lib folder, right? And you know how to do this from the previous phases, right? Go ahead and put it in here, add it to your location, and now you should be able to write JDBC code to connect to your database. I'll show you how to do that starting on Wednesday, though. All right? See you there.